Today we will be observing induced charge on an object and observing electric interactions to determine the charge of these objects. To do this, we will need Newton's second law, as well as Coulomb's law, to describe the forces at play in this experiment. We will also need to note that like charges repel and opposite charges attract. We will also be using the fundamental charge for calculations in this experiment. After completing the experiment, we were able to calculate a charge that was theoretically correct. For this experiment, we will be inducing a charge on two pieces of tape. We would predict that they would hold the same magnitude and sign of charge because they were charged through the same process. One tape will be set up in a hanging position, while the other one is brought towards the hanging tape. Once they're near each other, the hanging tape is repelled upward by the other tape. Once the system is in position, it is in equilibrium, so we can use the distance of separation in Coulomb's law, as well as Newton's second law, to determine the charge of these tapes. We were able to identify that the tapes were positively charged based on interactions with other objects of known charge. For this experiment, we will assume that the two tapes have equal charge and magnitude, and that the tape's charge is concentrated at the center, so they can be treated as point charges. From our observations, we found the mass and separation of the two tapes. We used the mass of the tape to determine the force of the gravity acting on the tape, and through Newton's second law and Coulomb's law, we calculated the charge of the tapes. Next, we created some Python code to calculate the charges in the same way. Here we include the constants. Next, the calculations of each of the forces. Then it calculates Q from the equation for Coulomb's law. Next, we can compare the model and hand-calculated charges, both of which are very similar, so we were successful in calculating the charge of the tape. Any difference in charge from the actual tape charge might come from how we handled the tape, or our assumption that the tapes can be treated as point charges. Finally, we conclude that the tapes were positively charged because electrons are not held tightly to the nucleus like protons are. If protons and electrons switch charges, we would see that these tapes were negatively charged because electrons can easily be knocked off of a material. That's why it's important to handle these charged tapes carefully, because the electrons can be easily transferred from one object to another, so the tapes can lose their charge. That's about it. See ya.